Welcome to qnawire.
In this question, we will understand the basic concept of the optics. So the question is a container which contains water up to a height of 20 centimeters, and there is a point source at the center of the bottom of the container, right? And the rubber ring of radius r floats centrally on the water. The ceiling of the room is 2 meters above the water surface, so we have to find the radius of the shadow of the ring formed on the ceiling if the radius is 15 centimeter, and we have to find the maximum value of radius for which the shadow of the ring is formed on the ceiling. Refractive index of water is given as 4 by 3, right? So first of all, we'll draw the diagram for this question. So this is the ceiling and the depth is 2 meters. (20 centimeters), right? So there is a point source and a rubber ring which is having a radius of 15 centimeters, right? So from this point source there would be a light ray which is coming at an angle of I and would be getting reflected at an angle of R. So this is X maximum. So as shown in the figure, we can say that sin I would be equal to 15 by 25. We also know that sin I by sin R is 1 by mu, which is equals to 3 by 4. So we can substitute the value of sin I. We get sin R as 4 by 5. Now from the figure we can say that x by 2 would be equal to 10R. Therefore sin R would be equal to 10R upon square root of 1 plus 10 square R. So when we simplify this, when we substitute the value of 10R, we get x by 2 divided by 1 minus x square by 4. We can substitute the value of sin R, which is 4 by 5, right? So we get x upon square root of 4 minus x square is equals to 4 by 5. Right? So when we simplify this, we get the value of x as 8 by 3 meters. So the radius of the shadow would be equal to 8 by 3 plus 0.15, which is 2.81 meters. So this is the radius of the shadow. In the second part, we have to find the maximum radius of the ring so that the shadow is on the ceiling. So in that case, let's say R is the maximum radius, right? So for maximum size of the ring, the incident angle should be equal to the critical angle. So in that case, sin C would be equal to 3 by 4, which is equals to R upon square root of 20 square plus R square. So when we simplify this, we get R as 22.67 centimeters. So this is the maximum radius of the ring.